Today we are discussing velocity time graph and motion. How the motion can be studied using velocity time graph. It is our main motto of this lecture. As you know, velocity is such an intermediate term that by using the velocity time graph we can achieve displacement traveled by the particle, and also on the other hand we can get details of the acceleration under which particle is going on. If we talk about the basic definitions involved with the velocity, displacement and acceleration, then we can easily say that by doing integration of velocity function we can achieve displacement, and by doing differentiation of velocity function we can get acceleration. As in mathematics, differentiation basically means slope of the curve, such as to get acceleration from the velocity time graph we just have to find the slope of the tangent on velocity time graph, and on the other hand to achieve the displacement traveled by the particle in a certain time interval we just have to find area under the velocity time curve, because integration basically means finding area under the given function. So for the given function, if we draw velocity time curve, then by finding area under this curve we can get displacement, and on the other hand by finding derivative or by finding slope of the velocity time curve we can get acceleration. So I am here first explaining about the velocity time curve, what it gives and what we can do from these curves drawn for a certain particle for which we are analyzing its motion. Just see, as we know, velocity can be achieved by derivative of its position with time. Means the velocity of the particle at any instant can be achieved by using differentiation of its position function with time. It can also be achieved using slope of the tangent on position time curve. In one dimensional motion, if we talk, then slope of this position time curve either may be positive or negative. Here positive slope means particle is going in forward direction. Forward direction means in the direction of increasing x. I have simply told it going ahead. Ahead means along increasing x, if x is the position of the particle. And for negative slope, my meaning is just that it is returning back towards the decreasing x. Right? What I have told you that to find the velocity, if we have been given a position time curve or a position time function, then to get the velocity of the particle, the instantaneous velocity of the particle, we just have to differentiate the position function if function is given, and is to find the slope of the tangent on xt curve if xt curve is given to us. Either given to us or we can find it by the initial informations given to us. Then, as we know, differentiation or finding the slope is basically just reverse process of integration or finding area under the curve. So we can say that by using the same relation x equal to integration of velocity function with time under a certain time interval, say t1 to t2, it gives us change in position. Here change in position may also be considered as, you can say, displacement. Here, displacement means change in position can be achieved by integrating velocity function with time. As we know, here integration means the process of finding area under velocity time curve here. So we can write it here that area under VT curve gives us the displacement. Displacement means change in position. So this relation between position and velocity of the particle can be utilized in both ways. We can find velocity from the position time relation or position time curve, and also we can find displacement from velocity time curve or by finding area under the velocity time curve. So first of all, I am just relating these two terms, change in position is displacement and velocity. We can find velocity time curve for the particle by using its positions at various time intervals. See, I am talking here about a particular case. Say, in a case which I am going to discuss with you, I am writing it here as case first. I am taking an event. Say, in the first case, we are considering a particle which is thrown with velocity u vertically upward. No doubt, the particle is thrown from the ground or the surface of the earth, because it is understood in this case, because if nothing is given and it is said that a particle is thrown vertically upward, it means it is understood that particle is thrown from the ground with some vertical velocity which is given to us, which is u units. Now what will we observe from this information which may be given to us in a particular question or an event? So just see what conclusions we may get from this information if it is given to us. We can consider this situation in this manner, that particle, say it is this, I am showing it here by the red dot on this paper on which we are discussing about the motion of the particle. The information given to us is that this particle is thrown with some velocity which is given here as u. Then it starts moving upward. Now it is understood that in this region, because this is the ground from which this particle has been thrown, so it is understood that there will be an acceleration which can be written as acceleration due to gravity, which is known to all of us. Here particle is thrown with velocity u vertically upward, and acceleration that particle have to face is g vertically downward. No doubt, for the motion of the particle while going upward, retarded motion is why, because the particle is going vertically upward and this acceleration due to gravity, it is acting vertically downward. So I call it to be negative acceleration, or motion of the particle is retarding motion. Just see, due to this acceleration in the opposite direction, or in other words we are telling it to be retardation, due to this retardation, speed or velocity of the particle is continuously goes on decreasing. It decreases depending upon the value of this g and initial value of the velocity of the particle. We can say it reaches somewhere in its path here. Here no doubt its velocity is say v1. No doubt this v1 will be less in magnitude with the u, because this negative acceleration is continuously retarding this motion, so its velocity first decreases. If we consider at some other time, say t2 time, we are talking about the particle's position here. Here say time was t1 and here say time is t2. So at t2, if we talk about the velocity of the particle here, then this v2, the velocity of particle at time t2, it is less than v1 and obviously less than u also, because u was the initial velocity with which it was shown. When it reaches at the highest point of its motion, vertical motion, then obviously if particle achieve this maximum height, then at this instant, say the time becomes ta. At this time ta, particle's velocity va, it becomes 0. It is the maximum height, means particle is not going further upward, so its velocity must become 0 at this point. So now here velocity becomes 0, but still vertically downward acceleration is acting. So due to that acceleration, particle starts accelerating now in downward direction. Here it reaches to this point, say at time t2 dash after throwing, then its velocity becomes here say v2 dash. It is the point to note that here if the level is same, while going upward particle has velocity v2 in vertically upward direction, and due to the retardation equal to g, particle's velocity becomes 0 at some other time ta. Then in the next time interval equal to the difference of time at t2 and ta, if the same time we now consider is t2 dash starting from ta, then in the same time, because of this equal magnitude of acceleration, while going upward, the acceleration was negative because particle was going upward, but now here particle is moving downward under the same magnitude of acceleration, so in the same time interval it achieves the same velocity which it was having at time t2. So here particle's velocity v2 dash is equal in magnitude with the v2, and while it reaches at the time t1 dash to the position where it was previously at time t1, then at the same position its particle's velocity becomes again equal to v1 dash. v1 dash is numerically equal to the velocity v1, but the sign means direction of motion is reversed. It again reaches at the same point from where it was thrown, then say time now becomes td. You can see here we are taking time to be 0 while it starts moving downward, and initially t equal to 0 was taken at the time of it is thrown. Then from 0 to ta, it is the same time which particle takes from falling from that point, that the maximum point from the maximum height of the particle, it takes again the same time, means we can say the time taken from 0 to ta is equal to the time 0 to td for downward motion. This time is for downward motion, this time is of upward motion. If we neglect air resistance and other effects, then the time taken to ascend its height and time taken to descend the same height will be equal. Means we can say these two times are equal if there is no air resistance or any viscous force acting on the particle.